Penicillin, the miracle and the menace. It's a story that's really about both of those things. It's about a discovery that saved, literally hundreds of millions of lives. But it also kicked off a crisis that, well, it unintentionally created. So yeah, this is the story of penicillin. Okay, so our story starts right here. This is the Sir William Dunn's School of Pathology at the University of Oxford. And that little plaque you see, it marks the exact building where a team of scientists took what was just a curious observation and turned it into a reality that would save countless lives. And believe me, calling it one of the biggest medical breakthroughs isn't an exaggeration at all. We're talking about something that completely changed the game for modern medicine. It saved hundreds of millions of people over the last 80+ years. It was, well, simply put, a revolution. So let's start with the good news, right? The triumph. How on earth did this, humble little mold become this incredible medical miracle? Well, it all kicked off back in 1928 with Alexander Fleming's sort of accidental discovery. But, and this is the key part, it was the team right here at Oxford that really cracked the code. They used everything they could get their hands on, even old bedpans, to ferment the mold and finally isolate. That breakthrough sparked this massive effort between the UK and the US during World War II to mass-produce the stuff. And of course, it all led to a Nobel Prize in 1945. And penicillin's impact? It was immediate, and it was absolutely massive. It basically kicked off what we now call the golden age of antibiotics. Think about it. Infections that used to be a guaranteed death sentence, pneumonia for instance, were suddenly treatable. This opened the door for huge advances in surgery, cancer treatments, you name it. But every golden age casts a long shadow, and the truly crazy thing is, the shadow from this one? People saw it coming from day one. This is what gets me. The guy who discovered penicillin, Alexander Fleming, is the same guy who predicted the crisis it would eventually cause. In his 1945 Nobel Prize speech, he stood up and basically warned everyone that if you misuse this drug, you're just teaching the microbes how to become resistant. He saw it coming right from the start. Unbelievable. And guess what? That's exactly what happened. We call this whole problem antimicrobial resistance, or AMR for short. It's pretty simple, really. It's when the germs, the bacteria and fungi, evolve and learn how to beat the very drugs we designed to kill them. They become superbugs. So how do they actually do it? Well, bacteria are super clever, incredibly adaptive. It's like they've got this whole toolkit of defenses. They can build stronger walls to keep the drugs out. They can install little pumps to literally kick the antibiotics out if they do get in. They can even change the part of themselves that the antibiotic is targeting, so it just doesn't work anymore. Or they can produce enzymes that just chew up the antibiotic before it can do any damage. It's basically a microscopic arms race. Okay, so Fleming gave this warning way back in 1945. How did we get from that single warning to the full-blown global crisis we're facing today? The answer is pretty sobering. His prediction? It's our reality now. Just look at this number, 4.71 million. That's how many deaths were associated with AMR in just 1 year, 2021. To put that in perspective, that's more than AIDS and malaria combined. It's just staggering. And it's not just the human cost, which is devastating enough. The economic hit is massive too. We're talking about AMR potentially wiping out $3.4 trillion from the world's annual GDP by 2030. That is, if we don't get a handle on this. And this stat really brings it home. 1 in 6. Just last year, 1 out of every 6 bacterial infections on the planet was resistant to the drugs that are supposed to cure it. So yeah, this is not some far-off future problem. It is happening right now, today. And we're not talking about rare, mysterious diseases here. The real everyday danger of AMR is what it does to common illnesses. We're talking about things like a urinary tract infection, or even just a kid's scraped knee getting infected. These simple things are becoming more and more difficult to treat, all because the standard drugs are starting to fail. Okay, so the logical question is, why don't we just invent some new antibiotics? And that, well, that's the other half of this crisis. If you look back at that golden age from like the 40s to the 60s, that's when we found most of the antibiotic classes we still rely on today. But now, that innovation pipeline has pretty much run dry. Why? Honestly, the economic model is just broken. For a big drug company, it makes way more sense to develop a drug for a chronic condition that someone takes for life rather than an antibiotic you only take for a week. The profit just isn't there. And the numbers really don't lie. Since 2017, only 12 new antibiotics have gotten approved. But here's the kicker, the real problem. 10 of those 12 are just slightly tweaked versions of existing drugs. That means the bacteria have already seen something similar. They have a head start on becoming resistant. We're just not finding brand new weapons for this. Okay, so that sounds pretty bleak, but it's not hopeless. Not at all. The fight is definitely on, and it's happening on all kinds of different fronts. And you know what? It's channeling that same spirit of collaboration that gave us penicillin in the first place. See, just finding new drugs isn't going to be enough to solve this. We need a whole multi-pronged attack. We have to be smarter about using the antibiotics we already have. We need way faster and more reliable diagnostic tests. We need to improve basic sanitation around the world. And we need to use vaccines to stop infections from even starting. And some of the new innovation is just, it's awesome. For example, back at Oxford, researchers are working on these new tests that can figure out exactly what bacteria is causing an infection and what its weaknesses are in just 30 minutes. Imagine that. Doctors can stop making educated guesses and use the perfect drug from the get-go. That's a huge deal in stopping resistance before it starts. Or check this out, this is wild. Scientists are developing these tiny nanoparticles. You activate them with ultrasound and they literally blast apart the slimy shields, they're called biofilms, that bacteria build to protect themselves. It's straight out of science fiction, but it's becoming reality. And this fight isn't just happening in high-tech labs. Get this. In Cambodia, there's a project that's using circus arts to teach people in local communities about how to use antibiotics properly. How cool is that? It's such a creative and powerful way to get a really important message across. So we have all this incredible work going on, but it all hangs on one single critical question. What happens if we fail? What are the stakes, really? Well, the answer is we go backwards. We'd be heading into a post-antibiotic era. A world where routine surgeries, chemotherapy, even a simple cut from a fall could become life-threatening again. It's a world we haven't seen in generations. The legacy of that miracle drug now depends entirely on us, on our ability to finally get a handle on the menace it helped create.